Welcome to the USC AI Future Symposium on Artificial Intelligence and Data Science. Thank you for joining us. Today is day 2 of our 3 days of great presentations about research and education in this area. My name is Yolanda Gil. I am Director of AI and Data Science Strategic Initiatives at the USC Information Sciences Institute and Research Professor in Computer Science and Spatial Sciences. It is my pleasure to start the meeting today with a session on education, where we will hear about USC's approach to curricula and education programs in these areas. Our first speaker is Cyrus Shahabi. Cyrus is chair of the Computer Science Department in the Viterbi School of Engineering. He's also director of the Integrated Media Systems Center. He is director of the Information Laboratory and professor of computer science and electrical engineering and research professor of spatial sciences. Cyrus?
Hi, thank you very much, Yolanda, for the introduction and also for inviting me to put a plug for our department and our covering of AI and data science. So I'm going to have a very short presentation. I'm going to start by giving you some quick facts about our department. As you see, we are a relatively large department. If you look at the number of students, especially, we have more than 4,000 students. We also have about 80-something faculty members. That includes our tenure track research faculty and teaching faculty members. I also listed our AAA AI fellows down there. I assume that given that the focus of the talk is on AI and data science, this might be relevant. As you see, Professor Yolanda Gil is one of our AAA AI fellows. Moving on, if I can, yeah. So I'll try to very briefly mention what we do at different, at both undergrad, graduate level, what we cover in AI and data sciences. So starting with undergrads and for AI, by design, we decided that at the undergrad level, we don't want to have special programs or special degrees in AI. So the general CSCI or computer science undergrad degree is what the focus is. And the reason was that we want the students to have the breadth at the undergrad level. We think they need to take typical courses, for example, data structures and complexity analysis, algorithm, as well as, for example, operating systems and so on. And then AI is another course, of course, that they require to take, but there is no emphasis on AI. However, we have these electives that if somebody is more interested in AI, they can use their electives to take more AI-related courses. So currently, for example, we added one course about 2 years ago, actually, on Introduction to Machine Learning. That's an example of an elective. And we keep adding. So the way that we add these courses is by creating special topic courses first, which is just this generic $4.99 number. And as we see how much audience we have for these classes, then they switch to their own course number. So for example, we have a course on AI for social good that we do see a good enrollment, and soon, hopefully, this would become a numbered course, for example. For the master degree, however, we do have specialized programs. So that's where we actually have our focus. So for example, we have 2 actually in our master program, one on data science and one on AI. So this one is the AI curriculum, and this one is the data science curriculum. I don't want to go to the details of the courses and so on, but the general design for both degrees, so both degrees have a little bit more number of units. So our general master program has 28 units, but these special programs, they have 32 units, so that's one extra course. And the way they are designed is that we have a number of required courses that the students have to take these courses. Our general master program, there's only one required course. For example, only analysis of algorithms is a required course for a general master. However, here we have more required courses because we want to kind of guide the students what courses they have to take. And then we have these groups that, depending on the focus the students want to go in AI or in data science, they take some courses from each group. So for example, in AI, we have these focuses on machine learning or NLP or computer vision robotics. And for data science, we have focus on whether they're interested more on the underlying data systems or on the analysis of data. So this is just quick breakdown of the number of our master students. As you see, the data science program currently has one of our larger programs as compared to the others, like computer network security and so on. This one is a big large program as well, but this is for students who come in without a CS background. So this actually has about 36 units requirement. Two other things I want to mention on this slide. The new AI master, the first cohort is coming this coming fall. So it's a new program. And out of the 773 students who agreed, who are admitted and coming to our program, 110 of them already are registered for this AI program. So this already shows a major demand for this program. And more than that, 106 of our current students actually already switched to this new master degree. We allow the current students to do that switch if they have the courses. The second point I want to make is that under the computer science, we also have a whole data science program. That's why I'm not emphasizing too much on data science. And Emilio, after me, going to go into the details of our data science program. Just a quick plug on our master program, especially, but in general, I guess graduates from both our undergrad and master, they end up in Silicon Valley companies, and various reports shows us in 4th or 5th place in placing students at top Silicon Valley companies. And this is basically a testament to the degrees that we provide. Finally, for PhD, as you know, there is no focus. I mean, PhD students, basically, they decide on their own focus by selecting an advisor and doing research in an area. We do have a healthy research going on in AI. So I just put a couple of numbers here just for 2020 on number of papers we had in ICLR and number of papers we had in AAAI. As you also know, a lot of our faculty play important roles in service in AI community. Like Yolanda was the president of AAAI until 2020. Sven Keng was the SIG AI chair, and so on. Here are just couple of quick slides showing various research happening in AI by our PhD student. I'm just going to flash them because we don't have much time, but just to show that there's a healthy research going on in the PhD program. With that, I think I would end my presentation. Thank you.
Thank you, Cyrus, very much. As Cyrus mentioned, to talk about the data science program, we have Emilio Ferrara. Emilio is Associate Professor of Communication at the Annenberg School of Communication and Associate Professor of Computer Science in the Viterbi School of Engineering. He's Associate Director of the Data Science Program and a research team leader at the USC Information Sciences Institute. Emilio is going to present the Data Science Program and lead us to our first session this morning. Emilio?
Thank you very much, Yolanda, and thanks for letting us discuss the programs today. So as Yolanda mentioned, today I'm going to present 3 programs: our master program in applied data science and undergraduate major and minor in data science. As you all know, data today powers everything. People tend to say data is the new oil. However, I prefer another analogy that I heard: data is the new electricity, because it really is behind every possible application, not only in computing, but also in many other different areas science and so on. So this program has been created many years ago, underwent a number of different name changes, but the core idea is the same. Some of the folks who are online today, including Cyrus, Yolanda, Craig Knobloch, and so on, shepherded this program and defined it as a program that allows students to understand and leverage large data environments and large data applications. So today we offer a variety of different educational opportunities to learn about AI and machine learning techniques, data mining, visualization, and the user interaction, user interface. Always with an emphasis on applications to real problems. So in the Master in Applied Data Science, students are expected to take, again, 32 units. And the program itself is designed to serve a range of students with different backgrounds, spanning from computer science undergraduate majors to students who have limited computing, coding, programming experience. Without going too much into the details, the program is split equally in 12 units of required courses and 12 units of elective courses. The required courses focus on foundational learning for data management, machine learning, data mining, and so on. And then there are a variety of different electives that can be chosen. Every student is free to pick their own path. And one of the most important things that we've been emphasizing over the last several years is offering in the space of AI ethics, fairness in artificial intelligence, privacy, as well as a number of courses that dive deeper into technical aspects of knowledge management, AI, focusing on some of the strengths that we have in the Department of Computer Science and ISI with researchers in knowledge graph, probabilistic modeling, and so on. The students are also allowed to take a selected subset of CSCI courses, and some of them are very popular. For example, applied NLP is especially popular in our student cohort. What kind of applicants we have? We have a variety of different applicants, as I said. We broadly categorize them in three distinct groups: students who come from an undergraduate degree in computer science, and they typically tend to be graduates from top computer science programs in the United States as well as abroad predominantly. And many of these students actually choose to pursue a career, including in research, for example, taking a PhD in computer science after graduation. We also have a number of students who are from other non-computer science disciplines in the realm of engineering or hard sciences, and they tend to be graduates from top domestic universities with focus on math, statistics, or other computing and engineering courses. And then we have also quantitative undergraduate degree students who have very limited computer science background. So they have had exposure to maybe one or two courses in computing. So it's a very diverse cohort. And as Cyrus hinted at, this program has been growing in popularity. So as you can see from these graphs on the right-hand side of the slide, the almost explosive, nearly exponential growth in terms of applicants over the last 5 or 6 years, going from a little over 200 to now almost well over 1,000. These programs are growing, and not only that, they are also receiving some acknowledgements and recognition in the community. I'm running out of time, so I'm going to briefly mention the fact that we have a BA degree in data science jointly with Dornsife. It offers both a major and a minor, and we currently have more than 70 students enrolled, plus 30 more students coming into the new cohort. The structure is similar to the previous program. We also offer then classes. For example, for the Master in Applied Data Science, the program is identical and you can take it online. It provides a lot of opportunities for students. We organize hackathons. There are student-led organizations such as Grids that do a wonderful job in bringing together this community of students around data science. And most importantly, we received a lot of recognition. So the program itself, the Master Applied Data Science, is ranked in the top 5 in the country, number 2 according to Best Colleges, number 4 according to Jerry Edge in 2011. Finally, the program's outcomes are very much in line with what we have seen with data science in the computer science department. So in the computer science program, saw a lot of Silicon Valley and otherwise computing and data science positions. So with that, I conclude this particular presentation, and I will jump right into our first session of the day, which is going to be on modeling behavior.